So here we have to explain the concept of the definition of derivative of a real function at a point in its domain, and re- and the relation in between differentiability with and continuity. So we know that the derivative of a function f of x at x equal to c is defined by f dash x, which is equal to d by dx of f of x, that is equal to, so f dash x at x equal to c, or d by dx of f of x at x equal to c, that is equal to, so we can write this as f dash c actually, f dash c, which is d by dx of f of x at x equal to c, that is equal to limit h tends to 0 f of c plus h minus f of c by h. And and we also know some rules of the algebra of derivatives, that are, first is mm, f of x, plus minus g of x d by dx of that is equal to d by dx of f of x plus minus d by dx of g of x. Or simply we can write it as u plus minus v whole dash, that is equal to u dash plus minus v dash, where u is f of x and v is g of x. This can be actually also written as f dash x plus minus g dash x. And the second rule is uv whole dash, that is equal to uv dash plus vu dash. Or we can tell that f of x into g of x whole d by dx of that is equal to f dash x into g of x plus f of x into g dash x. And the third rule is the quotient rule. The second rule is called as the product rule or the Leibniz rule, and the first rule is the sum rule and difference rule of differentiation, and second one is Leibniz rule or product rule of differentiation, and the third rule will be the quotient rule of differentiation. So that is u by v whole dash, that is equal to v u dash minus u v dash by v square. Or we can say that d by dx of f of x by g of x, d by dx of f of x by g of x, that is equal to g of x into f dash x minus f of x into g dash x by g of x whole square. So the relation in between differentiability and continuity is that there is a theorem, it states that if a function f of x is differentiable, function f of x is differentiable at x equal to c, then it is also continuous at x equal to c. Then the function f of x is also continuous at x equal to c. So if a function f of x f of x is differentiable, if a function f of x is differentiable at x equal to c, it means that f dash x, f dash c, which is equal to limit h tends to 0, f of c plus h minus f of c by h. So this limit should exist. So this exists. So it means that the left hand derivative, so it means then the left hand derivative, which is equal to f dash c minus h, that should be also equal to the right hand derivative, which is equal to f dash c plus h. Now, therefore, the left hand derivative, we can write it as L f dash c, that is equal to limit h tends to 0, f of c minus f of c minus h by h, and r f dash c, that is equal, which is the right hand derivative of the function at x equal to c, that is limit h tends to 0, f of c plus h minus f of c by h. And then so here we have to use all the rules of the derivatives, which are, we know that d by dx of x power n is nx power n minus 1, and d by dx of sine x is cos x, etc. So all those rules we have to use it here. So a list of these rules will be told in the subsequent videos. Hope you have understood. Thank you.